Yeah. Allow me to record the session so that if you miss something, you can watch the recording. Questions? Timir, you're using two devices. Okay. All right. Now, if you don't have any questions, I already sent you in your WhatsApp group. I sent you some files. The first one is the PPT file. So semoga nanti saya tidak lupa. Now, the first thing that we are going to have a look at is test of normality. Basically, test of normality is a prerequisite test that is conducted before we can do further parametric tests. But before we go there, I would like to make sure that everyone here understands about what normal distribution is. So if there is a question, what do you know about normal curve? Okay, so basically, when we are talking about normal curve or normal distribution, we are talking about this bell-shaped curve. We call it bell-shaped curve because it looks like a bell. And this one, right in the middle of the bell, you have the X bar, or this is the mean. X bar is the symbol for mean or rata-rata. And oh, kok nyantol-nyantol dari tadi. Come on. And the second one, we do have this one, standard deviation. 1 standard deviation, 2 standard deviation, 3 standard deviation, -1 standard deviation, -2 standard deviation, and -3 standard deviation. What does this mean and standard deviation mean? So for instance, you have you conducted a test and then you got like 15 as the mean of the test and the mean of the group, and then for the standard deviation you get 3, for instance. So here as the mean you get 15, and then this one, if you're saying that we do have 1 standard deviation, it means 15 plus 3, so this one equals to 18, and 2 standard deviation means 15 plus 2 standard deviation, or this one equals to 21. So plus 3 standard deviation equals to
24.
24. Okay, so what about minus standard or -1 standard deviation? This one equals to
12.
12. Kurangi 12, kurangi 3 ya. -2 standard deviation equals to
9.
9, and -3 standard deviation equals to
6.
6. So basically, when we are talking about normal distribution, we are talking about this bell-shaped curve. What does this bell-shaped curve mean? It shows us, it tells us that the majority of the scores lies between -3 standard deviation and +3 standard deviation. For instance, tadi skornya itu rata-rata 15, maka sebenarnya skornya itu berada antara 6 sampai 24. But the rata-rata or the mean is still 15. Okay, and here 99.7%, this is not 100%, 99 something percent, of the score lies between -3 to +3 standard deviation. What about the rest of the scores? Ada di sebelah sini, sisanya ada di sini, and we call these scores as outliers. Okay, so they are outliers yang tidak berada di antara -3 +3 standard deviation. Okay, and then 95% of the scores lies between -2 to +2 standard deviation, and then 68% of the scores lies between -1 and +1 standard deviation. What does -1 +1 standard deviation? If we are talking about -1 +1 standard deviation, kalau tadi rata-ratanya 15, maka yang ada di sini yang memiliki skor antara berapa tadi 21 sampai 24 itu adalah orang-orang yang excellent. 2.5% of the distribution is excellent people. Di sini 2.5% of the distribution itu yang paling kurang excellent di sini. Yang berada di antara 6 sampai 9 tadi. Ada yang berada di sini normally. Okay. And then the majority of the scores tadi antara 12 sampai 18. The majority of the scores lies here. Okay, so this is again and again a normal distribution. This is what statisticians always dream of. This means that in reality, kadang data kita tidak senormal ini. Ada sedikit penyimpangan dan lain-lainnya. Nah, why the hell, kata Andy Field ya, why the hell do we need to learn about this normal distribution? Okay, I'll talk about it in a bit. So on the next slide, we find this one. Why do we need to know about normal distribution? About how to run it, it's simple, but why do we need to know about this normal distribution? Okay, so pretend that this is you. Okay, this is you, and you are a researcher. You have your data here. Okay, and then you want to do further analysis. Oh, you want to do further analysis using parametric test. What is actually parametric test? Parametric test is a test in which from the result you can generalize it to the whole population. Dulu masih ingat ya, we do have sample, we do have population, right? So our sample will have to really represent the whole population. Jadi sampelnya itu kalau populasinya tadi normal distribution, ada yang kurang, ada yang sangat pinter, ada yang sedang-sedang, your sample will have to resemble it. Will have to represent it. Ada yang kurang, ada yang tengah-tengah, ada yang lebih juga. So here, if you find that the distribution of yours, the distribution of your sample is normally distributed, the data in your sample is normally distributed, nanti hasil dari analisis di sampel ini, you can generalize it for the whole population. Let me give you a clear example. For instance, I got a theory saying that kalau mahasiswa itu minum cerebrofit yang di dalamnya ada ginkgo biloba, they can concentrate better, they can learn better, and finally they can perform better. That's the theory, what the theory are saying. Okay, saya ingin nyoba mahasiswa bahasa Inggris S2 di Jogja, kayak gitu enggak ya? Okay, that's my population. Mahasiswa bahasa Inggris S2 di Jogja. The thing is, it is almost impossible for me to collect the data from every single student in Jogja, PBI S2. That's why I took a sample from the population. Sampelnya karena di Jogja ini ada universitas terakreditasi A, B, dan C. So I'm going to take some from A accredited, some from B accredited, and then some from 3 accredited. They will represent, misalnya ini anggotanya 500, 400, 300, then I'm going to take some from this, and some from this. So for instance, I take 50 only. Then this 50 will have to represent the total of the population. And then when I conducted the study and I find that, okay, ternyata dari 50 ini, cerebrofit does help them to concentrate better. Cerebrofit does help them to perform better. Then I can generate, okay, dari sampel 50 ini, I found that cerebrofit helps them concentrate better. It means I can apply it to the whole population. Meaning that every master students of PBI in Yogyakarta, if they take cerebrofit, they can concentrate better, they can perform better. You get the point? The thing is, sometimes our sample do not represent the whole population. Nah, kalau sampelnya di sini tidak mewakili populasi, distribusinya misalnya tidak normal, you cannot do this generalization. It only applies to the sample. So, if you want to do this generalization, you have to run parametric tests. And some examples of the parameters are this one. Okay, so before you do these different types of analysis, you'll have to go through test of normality. Ada di sini. Oh, ada di sini. Okay, you'll have to go through test of normality. The first gate before you can run further analysis is test of normality. If your data are normally distributed, you can go ahead with parametric tests. If your data are not normally distributed, then you have to do non-parametric tests. That means you cannot generalize your data. Your findings, you cannot generalize your findings. Your findings only apply to the small group of sample that you collected. Okay, now, so basically, test of normality is the first gate, is the requirement, prerequisite before you can conduct parametric tests. Okay, now I'll stop here to check whether you do understand the concept of test of normality and why we need to conduct this test of normality or not. So if you have any questions, silahkan. Going.
Sorry, sir.
Yes, please.
So if in parametric test we have correlation and regression analysis, how about in non-parametric test, sir? What do we have in non-parametric test, and then what the functions of parametric test itself? Thank you.
The function of?
Non-parametric test.
Okay, the non-parametric test, you can run non-parametric test when you find that after the prerequisite analysis or test of normality, you find that your sample is not normally distributed. And some examples of the parametric tests itu nanti ada Wilcoxon and some other types of tests. Nanti ada di situ. Just Google it and then you will find it there. In SPSS, you can also find non-parametric tests. But we are not talking about them first. We are talking about this one first. Supaya nanti tidak terlalu bingung. But here we do have non-parametric tests like Wilcoxon and some other different type of test. The function are similar. Kalau ini korelasi, nanti misalnya Spearman itu juga korelasi, but you cannot generalize your findings. Kalau ini uji beda, Wilcoxon itu juga uji beda, but you cannot generalize your findings to the whole population. You get it, Mbak Arnita?
Yes, sir. Thank you.
Okay, thank you, Mbak. Okay.
Sir,
Yes,
can I
please.
mention, sir?
Yes, please.
So we use parametric test if our data normal, and we use non-parametric test if our data distribution is not normal, like that, sir.
Yes. That's what the majority of experts say. Okay, why did I say that? I'm going to show you something. Okay. Okay, so can you see my screen? So this is an article by some authors from Iran, and this article has been cited by 3,997 different citations, if I'm not mistaken. 3 citasi lagi dapat piring dia, atau dapat bonus gula atau apa itu misalnya. But so here I just want to show you that this article has been cited by many different authors. And what I want to show you from this article is this one. Now, please read this paragraph. You get the point? So what does this paragraph say?
It's about this, sir. The abnormal data is a normal data actually, and for abnormal data we can still apply the parametric test.
Exactly. So the majority of experts, especially in UNJ, say that hidup atau mati, you'll have to do test of normality to your data. And if your data are normally distributed, you can run parametric tests. But if your data are not normally distributed, you have to run non-parametric data. You cannot run parametric data. The thing is, out there, internationally, some experts, or there are many experts who do not believe in the normality of your data. If you have a large size of sample, let's say more than 30 or 40, then automatically your sample is considered to be normally distributed. It means you do not need to run tests of normality, and your data are treated as normally distributed, and you can run tests of parametric for your data. This is what this article is trying to say. Okay, even some experts say that normality is a myth. Real normality is a myth. So what I want to say is from this article is that experts are not always in the same boat. I mean, they sometimes, or most of the times, experts do not get along one another. Then, Pak, lah kalau expert ini bilang A, expert ini bilang B, kita di mana posisinya? It's up to you. As long as you have references, as long as you have backup theories, you can go with any direction. You can go with any paham. You can go with any perspective. But you have to make sure that your backup theories, your backup references are strong enough. Kalau sudah di-set ribuan, it is strong enough. That's why kalau nanti Mas dan Mbak lihat di luar negeri artikel jurnal internasional, they normally do not run test of normality because they have got, I mean, especially if they have large number of samples. You get my point? Yes. Kalau di UNJ kadang diminta, kadang ada yang tidak menanyakan itu. Okay. Now, yes, any questions?
I'm sorry.
Yes, please.
May I have a questions?
Please.
Okay. In doing a parametric test, should we have a balanced sample data? Like, for instance, in the class A, I get 25 students, and then in the class B, I get 20 students. So, I mean, like, should I make it them balance like a 20-20?
Okay. Yeah, I get the point, Mbak Nur Aziza. So basically, if you find that your sample is large enough, let's say 30, at least 30 in your class A and another 35 in your class B, well, it is fine. But if you have 15 and 20, you'll have to run test of normality because it is less, they are less than 30 or 40. Okay, so in running parametric or non-parametric tests, as long as your sample size is large enough, more than 40, more than 100, for instance, then you do not need to really worry about the number of sample in each group. Tapi kalau jumlahnya sedikit, ya, you need to worry about that. You need to check the normality of your data. Why do we use the number 30 here? Okay, it is because if we have 30, then standard error of measurement is normally low when we have 30 respondents as our sample. And this standard of error normally increases if we have less than 30. If we have more than 30, the standard of error normally decreases. That's why in statistics, we do have this slogan, the more, the merrier. Okay. Yeah, I hope that answers your question, Mbak Nur Aziza.
Yes, sir. Thank you.
All right, no worries. Now we'll go ahead with our slide. Where is it? Where is it? So again, I'm going to, what is it? I'm going to stress out that this one, In statistics, ini tadi yang pertanyaan Mbak Arnita ya. We do have what we call as test of normality as the main gate before we can run further analysis. If you find that your data are normally distributed, then you can go ahead with parametric tests like t-test, ANOVA, and then correlation and so on. So this is your way, this is your direction. But if your test is not normally distributed, then you have to go to the other way. Wilcoxon, and then Spearman, and Mann-Whitney, and some other types of non-parametric tests. Their function are similar. Misalnya Spearman-Brown ini untuk korelasi. Wilcoxon atau Mann-Whitney ini misalnya untuk uji beda, and so on. Ini sama dengan t-test and correlation in parametric test. Ini hanya untuk memperjelas saja ya. I don't know about these two great actress and actors, but yeah, I just like their faces. I mean, mungkin kalau yang cowok pasti suka yang ke kanan, yang cewek pasti suka yang kiri, and so on. Drakor especially. Okay, all right. Now, I hope we already cleared the ground related to test of normality. So the first thing in our class is knowing the concept. Why and why do we need to run this type of analysis? The reason behind it. You get the point, yeah, everyone? Yes. Now, if you already know about why we need to run the analysis, the next step is how to run the analysis. How do we run tests of normality? Okay, so these are the steps. Later, we are going to have a look at how to run the analysis nanti dengan SPSS. The first one, you need to click the analyze, and then descriptive, and then explore, plot, and normality plots. We are going to do it step by step in a bit. But before we go there, you need to see it later. You will find it later that the result from this analysis, you will find two different tables as the result of this analysis. The first one is the Kolmogorov-Smirnov table, and then the second one is Safirovic's table. Okay, it's up to you. If you want to use the Kolmogorov-Smirnov, it's okay. If you want to use the Safirovic, it's okay. Because there are different experts who are saying different things. Ada yang saya suka Kolmogorov-Smirnov mungkin karena dia dari Russian and France. Saya suka Safirovic karena dia dari US and the Allies, misalnya. Itu ya, pasti ada Timur dan Barat itu ada. But how do we read the output, sir? Okay, later you are going to find that in the table you will find the sig value. If the sig value of the Safirovic test or Kolmogorov-Smirnov test is greater or bigger than 0.5, then your data are normally distributed. But if the sig value is below or lower than 0.05, then your data are not normally distributed or deviate from a normal distribution. This may sound a bit abstract to you, but we are going to have a look at this. Okay, more than 0.05, that is normally distributed. Less than 0.05, that is not normally distributed. You may want to snapshot this screen. You may want to take a picture on the screen, then, because we are going to run the analysis in a bit. Okay, now we are going to run the analysis. Kindly have a look at your assignment 1 data. Has everyone opened this data? Assignment 1. Has everyone here now? Is everyone here now? I sent the file to your WhatsApp group. Sudah membuka ini semua?
Yes, sir.
Ada yang belum? Raise your hands yang belum. Sudah semua ya? Cool. All right, now, one thing that you need to remember is that you can only run tests of normality for scores or ratio type of data. You cannot run them for nominal data. Misalnya SES atau gender kok diuji normalitas ya tidak masuk, tidak jalan. Because you cannot run any mathematical operation to nominal data kecuali jumlah and frequency. Okay, you can run no test of normality into in your what is it? Apa ini tadi namanya? Ratio or scores. Boleh kalau di rasio atau score boleh. So we can only have this one. Intro to research, research design, thesis, high school math, statistics, and academic stress. Okay, now how do we run this, what is it, test of normality? Kalau tadi urutannya, you go to analyze, and then you click on descriptive statistic, and then you choose explore. Is everyone here now?
Yes, sir.
Yes. Okay, click on this one. Yeah. Okay, now you have some nominal and what is it, ratio data. We only choose the ratio data. Let's have a look at introduction to research method dulu. Yang lain kita tinggalkan dulu. Just introduction to research method. Okay, introduction to research method, move it to the right one. Nah, ini kita lakukan ini untuk uji normalitas untuk tes yang nanti fungsinya tes yang bersifat korelasional ya. Nanti untuk tes yang bersifat uji beda, kita misalnya berbasis gender, nanti ada faktor kita taruh di sini. For now we are not running test of normality for uji beda. Kita masuk ke test of normality for uji korelasi dulu. Besok sebelum uji beda, we are going to check test of normality for uji beda. Again, for now, we are running test of normality for uji korelasi. Okay, please move, what is it, introduction to research to, to the right column, dependent list. And then click on statistics. So you will find outliers. Ask for outliers kalau ada. What is outlier? We are going to talk about outlier in a bit. Okay, click continue. And then click plots. And then click normality plots with test. Done. Click continue. Is everyone here now?
Yes, sir.
Ulangi,
Sir,
Pak.
could you repeat the plot, sir?
Yeah, yang mana? Yang mana? Plots. Okay, go to statistics first and then click outliers here. Outliers, click it and then continue. And then click again plots and then choose normality plots with test. And then click continue. Is everyone here now?
Yes, sir.
Yep.
Yes, yes. And then click OK. Yes, so here on the left column, you will find extreme values. It shows the outliers. You will also find test of normality as the output of the test of normality. Now we'll see the results of test of normality first. Okay, tadi aturannya kita lihat the first table or the second table. Kolmogorov-Smirnov or Safirovil. Sometimes they get along, but sometimes they do not get along. But most of the times they get along. Rukun. Sama hasilnya maksudnya. Tapi kadang tidak rukun juga. Okay, so here what you need to check is this one, this column, the sig column, or this column, the sig column. Tadi aturannya seperti apa? Kalau signya seperti apa tadi?
More than 0.05. means
more
the
than
data normal.
0.05, then the data are normally distributed. But if the sig value is less than 0.05, then the data are not normally distributed. Okay, now we check the sig value here, the sig column here. Is introduction to research method data or are the data normally distributed?
Indeed, sir.
Berapa ini?
200.
200,
0.200, right? Atau kita baik buka 0.200. Is it lower or bigger than 0.05?
higher, sir.
Higher or bigger, larger than 0.05. This means that this set of data is normally distributed, or the data on introduction to research methodology are normally distributed. This is how to first run the analysis and read the output. Okay, now if you have any questions, Mas dan Mbak, silahkan ditanyakan terlebih dahulu. Kalau enggak, kita coba dengan data yang kedua. Okay, we are going to run another test of normality for another set of data. Kalau tadi intro to research method, kita coba sekarang research design. Click it to the right. Plots-nya masih ada, oke. Statistiknya masih tetap ada, outliers. And then click OK. Now, we check on the test of normality. Okay, are the data on research design scores normally distributed, Mas dan Mbak? Hello?
Yes, sir.
Yes or not?
Yes.
Yes. How do you know that it is normally distributed?
More
Because
bigger
Okay.
than 5.
The sig value is more than 0.05, right? Now, this is how to run and read the results of the analysis. Now, please do the rest. Please do the same thing for the rest of the data. Bisa dilakukan sekali ya itu ya. Ini bisa dipindah ke kanan semua. Ini bisa langsung dipindah ke kanan juga bisa. I just wanted to show you the step by step. Karena kalau bareng-bareng biasanya agak bingung. Okay, now you do the rest of the analysis. The test of normality for the rest of the variables. While I'm going to prepare for attendance list checking. Oke, sambil presensi ya. Sambil membaca hasil itu. Mbak Aulia, are you in?
Yes, sir.
Mbak Reliska,
Yes, sir.
Sofyan? 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 No.
Yes, sir, I'm here.
Okay. Mbak Dwi Pristiawati? Dwi Pristiawati? Dian Islamiati. Is there Octaviani? Octaviani? No. Maulizati is there. Nur Aziza is there. Uswatun?
Yes, sir.
Pratiwi is there. Ratih? Ratih?
Yes, sir.
Okay. Askardia?
Yes,
Askardia?
sir.
Yes. Miftahul?
Yes, sir.
Yes, sir.
Amin?
I'm here, sir.
Arnita is there. Nurul is there. Yeni? Yeni Widyarti. Okay. Aulia?
Yes, sir.
Dede? Dede? Dimiar is there. Norasia?
I'm sir.
Rifat?
Yes, sir.
Sucidin?
Yes, sir.
Ifti is there. Fitri? Fitri? Queen?
Yes, Pak.
Eskananti?
Yes, sir.
Yudo?
Yes, Pak.
Okay. Yeah, thank you. Oh my goodness. Ini tadi yang izin siapa ya? Pratiwi, okay. Now we are going to have a look at the output from our analysis. Oh, sorry. The wrong screen sharing. Test of normality. Research design and intro tadi sudah ya. Okay, we are not talking about the first two. The first two has been discussed before. Now we are going to have a look at thesis score. Is this set of data normally distributed, Mas dan Mbak?
No.
No. How do you know it is not normally distributed?
Lower than the sig.
Okay.
Right.
All right. The sig is lower than 0.05. 0.05. Okay. Thank you. Sorry, this is an 0.05. What about high school math scores?
Normal.
Normal,
sir.
Normally distributed because the sig value is higher or larger than 0.05. Statistics?
Normal too.
Normal.
Okay.
sir.
From Kolmogorov-Smirnov, it is normally distributed, but from Safirovic, it is not normally distributed. But as long as you have, like a references, misalnya saya pakai Kolmogorov kok Pak, saya nggak pakai Safirovic, it's okay. Kalau saya pakai Safirovic Pak, ya jangan ganti-ganti dengan yang Kolmogorov. Make it consistent. If you have some test of normality in your report nanti. Yang penting konsisten, jangan yang atas pakai Kolmogorov, bawahnya pakai Safirovic, nyari yang normal misalnya. No. As long as you have, Kolmogorov, then use Kolmogorov. If you use, if you use Safirovic, then use Safirovic. This is due to the sensitivity of this test, some types of tests to the number of n atau jumlah sampelnya. Jadi kadang kalau jumlah sampel itu membuat sensitif tesnya. Jadi kadang terekam sebagai tidak normal, kadang terekam sebagai tidak normal. That's why tadi dikatakan oleh si artikel yang 3997 citation tadi bahwasanya normality is a myth atau you can consider your data as normally distributed kalau more than 30 or 40. What about academic stress? Is it normally distributed?
No. No, sir.
Oh,
Okay. Yes, thank you. Now the thing is, misalnya thesis score. Loh ini data kita tidak normal, Pak. What happens then? What happens next? Should we do this thing? Should we cancel our research? No. Should we find different sample? No. A different sample, sorry. Different group of sample? No. Should we use non-parametric? Yes. Should we use non-parametric test? Yes, but wait. Wait dulu ya. Nah, what we can do is first, kita mungkin bisa mendelete outliers. We may find some outliers in our data. The one that I told you, remember? Yang di atas plus 3 atau di bawah plus 3. They are outliers. Sometimes you find some outliers. But the thing is, how do we recognize our outliers? First, some outliers are the ones who are cheating. Cheating from their friends, cheating from the book, cheating from the calculator, cheating from their computer, and so on. You can delete these cheating students. Or those who came late. Let me give you an illustration. If you have a test of 50 items, and then you allow the students to work on it for 120 minutes, and then someone or two of your students came ketika menitnya itu sudah menit 110 misalnya. Berarti tinggal 10 minutes left, right? And then he has to do 50 items. 50 items within 10 minutes. Do you think that the result of his working on the test or the result of their working on the test itu akan valid atau tidak?
Not valid, sir.
No,
Not
sir.
valid.
Oh.
That's why daripada mengotori data, membuat data itu tidak normally distributed, karena mungkin nanti akan mungkin menjawab A semua atau B semua atau C semua atau dibatik A B C D E A, buat zigzag seperti ini malah nyusai. You can delete them. Okay? And then those who skipped most of the questions, similar to the previous case. Those who came late. Misalnya hanya datangnya juga sama awal, but then he or she didn't do most of the didn't answer most of the questions. Then just delete that person. Those who were identified as non-responsive or uncooperative sample. Misalnya ya tadi jawabnya A semua atau B semua atau C semua atau zigzag itu tadi. The thing is, this doesn't apply to survey. This applies mostly on tests. Okay? Nah, kalau ada yang nyontek, kalau ada yang datang terlambat, men-skip pertanyaan, dia nggak kooperatif, then just delete them. Gimana caranya kalau secara statistik, Pak? This one are based on observation, right? But SPSS also helps you to identify these outliers. How do we know these outliers? Okay, we ask SPSS to do that for us. Now you can ask this extreme value. Click on this extreme value. Tadi kan excess of normality, now click on this extreme value. Tadi yang tidak normally distributed kan thesis ya. Okay, now you find that from this information, have a look at thesis. From this information, ada yang nilainya terlalu tinggi misalnya. Siapa itu? Itu student number 14, student number 9, student number 31. Kita coba lihat saja, benar enggak student number 14 itu terlalu tinggi. Mungkin dia nyontek misalnya, tesis itu boleh nyontek. 766 student number 14. Let's check our data. 14 thesis score 766, benar ya? Now if you find that this student is cheating or misalnya tadi apapun yang jelek-jelek itu, baik yang apa namanya tadi extremely high or extremely low, ini kan extremely high, yang di sini extremely low, itu nanti silahkan boleh dihapus. Misalnya ini terlalu rendah, anak nomor 54 ya boleh dihapus. As long as you have large number of sample. Kalau sampelnya hanya 30 ya jangan dihapus lah. Nggak usah pakai uji normalitas misalnya. Kalau sampelnya misalnya ini, oh saya punyanya banyak kok Pak, saya punyanya 65, ya sudahlah boleh dihapus saja. Delete this one. Misalnya. And then you may want to run for another test of normality. But this doesn't always guarantee that your data will turn into normally distributed. This is just an effort that SPSS tells you, ini yang boleh dihapus, ini yang boleh dihapus. Okay, now, do you get my point? Yes. If you have any questions, silahkan. Karena this is the basic concept. We already learned about the basic concept of test of normality, the underlying reason why we need to run the test of normality. So most experts or many experts believe that we have to run it before testing using not parametric tests, but some other experts believe that normality is a myth. No need to run for test of normality. Second, you know about how to run the analysis. And then third, you learn about how to read the output. The last one will be how to write the report. Now, I'll give you 10 minutes to Google how to write the report for test of normality. Silahkan, Google it first. I don't want to spoon feed you. Now you Google it first. Find some information on how to write the report for test of normality. Silahkan. I need to turn my camera first because I need to do presensi wajah ya. I'll be back in a minute. So, saya lupa Mas dan Mbak. Nanti kita untuk yang jam 1 kita mulai 12:30 bisakah? Jadi yang mas-mas nanti makan lebih awal ya supaya setelah Jumatan bisa langsung masuk. Atau kalaupun terpaksa ya disambi makan enggak apa-apa kelas kita karena emergency. Saya itu susahnya kalau hari Jumat seperti ini karena banyak sekali pasti kegiatan itu ditumpuk hari Jumat karena asumsinya hari Jumat itu tidak mengajar. Nah, sedangkan saya di Jumat itu ada 3 kelas ya yang repot ya karena sebagian besar memang tidak mengajar dosen di hari Jumat. Gitu ya, oke ya. Ya, 12:30. Yes.
Kalau misal emang sholat Jumatnya apa ya kelarnya lebih dari 12:30 nggak apa-apa kan maksudnya?
Enggak apa-apa. It's okay. Yeah, it's okay. Yeah, thank you. Now, it's already 10 minutes, and can someone share your finding on how to write or how to report the output from test of normality? Silahkan. Anyone, please. Please, yuk.
Still digesting, sir.
Okay, yeah, all right. If you are still digesting how to write the report, then it's okay.
Can I just read it, sir?
Yeah, and can you write it on the present it using the share screen, Mbak?
Oh,
Ya. Atau kalau sudah ditulis ya share it to your friends. I mean through the share screen.
belum Bapak karena hanya membuka catatan zaman dulu.
It's okay. Oh, all right.
Is that true, Bapak?
Kind of. Tapi the thing is, working with statistic is sometimes pretty fixed. I mean gini, enak kalau yang tidak mau merubah-rubah. I mean how to write the report in quantitative result is kind of fixed. I mean, I'll try to show it to you. It stops working. This one. Wait a minute. Let me share my screen first. Mas dan Mbak, I have got this website, Statistic Alert. This website is pretty powerful for our next classes, for our next sessions, because this website allows you to see the basic concept of test of normality and other types of tests. And this website also tells us about how to do the analysis together with how to write the report. This is the one that I meant to you. I mean, ini kalau yang tadi mau digunakan untuk uji beda. Ada faktor listnya. Kalau kita tadi kan karena tidak menguji beda antar dua kelompok, satu kelompok saja, maka tidak ada faktor list. Ini yang khusus untuk uji beda. And then this is how to write the report. Tadi mana ini? Where's the other? This one. As the sig value under the Safirovic column is greater than 0.5, we can conclude that for this particular set of individual is normally distributed. This is just an example of how to write the report. So this kind of expression is pretty fixed. Okay, and this website also tells you about different types of analysis. But what you need to do is to write the name of the test first and then type statistic-led or statistic-led then type of analysis. Because if you go to statistic-led and then click on it and then you search for the type of data, nanti diminta untuk bayar biasanya. But if you type like this one, statistics-led test of homogeneity, for instance, nanti muncul. Oh, sorry, not this one. Find the statistic-led. Come on. This one, misalnya one by ANOVA atau t-test of correlation. Person product correlation and some other types of correlation ada di situ. Misalnya ini ada introduction-nya, ada assumption-nya, kemudian ada how to run the analysis, and then how to read the output, and even how to write the report ada di sini. It's pretty powerful. For the next types of analysis ada juga up to regressions, the one that we are going to learn in our course. Statistic-led. Remember, type statistic-led first and then types of the analysis, or type of the analysis then statistic-led. Don't simply Google statistic-led and then click it and then search for the type of analysis. Dulu satu kelas itu bingung, Pak, kami harus bayar gini-gini. I never been asked to pay anything when I use this website. Okay, now questions, if there is any.
Bapak,
Yes, please.
how if the result is how is the result of the data is not normality, but the researchers wants to normal? How the solution about that?
Just leave. I mean, just skip the test of normality. Yeah, because if your data is not normally distributed, the first thing that you can do, if you have some outliers, delete the outliers. Okay, if you cannot make your data normally distributed, skip the test of normality. As long as you have references, backup theories to back up your arguments. Okay, Mbak Reliska, but most of the times, kalau di UNJ biasanya you will be asked to run test of normality, especially if your examiners are from PEP. They will ask you to do test of normality. But if they are not, they don't know much about test of normality, they will not ask you. And in international journals, I've been publishing in some international journals, and they never asked for uji normalitas. Okay? Yeah. Yeah. Any other questions, please?
May I, sir?
Yes, please, Mbak Pratiwi.
You told in the previous that we may delete the higher one, or we may also delete the lower, or only the higher, sir. Thank you.
You can delete both or one of them until you find your data normally distributed. Kalau bisa. But sometimes you find that even after deleting these highest and lower scores, your data stay not normally distributed. Itu bisa terjadi. Okay, because if we are talking about possibilities, there are some possibilities, right? First, you delete the highest scores, and then your data is normally distributed. Second, you delete your lowest data, and then your data set is normally distributed. Third, you need to delete both highest and lowest, and then your data will be normally distributed. And then fourth, you already delete two of them, but your data are not normally distributed. So there are possibilities, okay, of making your data normally distributed. Kalau enggak, ya sudah, skip it.
Okay, sir. Thank you.
Yes, no worries. Sudah sembuh vertigonya?
Still, sir. And I got fever.
Do you take Mestigo?
Yes, I try Mertigo too.
Just calm down, because I'm a vertigo as well. I mean, I suffer from vertigo a couple of days ago, and what I normally did is just like having self meditation and telling myself that I'm fine, I'm okay, I'm fine, I'm okay. Take a deep breath, and then, because my vertigo comes from my asam lambung or acid, I mean, dari asam lambung itu naik. Dulu saya memang mulai vertigo ketika studi lanjut. Kayaknya mikir terus studi lanjut. That's why no wonder.
Yes, sir. Thank you, sir.
Yeah, no worries. Okay, any other questions, Mas dan Mbak? Belum? Oke. Nah, sudah mulai memanas ya kepalanya ya. Minggu depan mungkin semoga lebih panas lagi, because we have 5 weeks left for, different types of analysis. But don't worry, this 5 week is not that short, so we can still like revisiting what we already did. And then if you have any questions, you want us to like review it first, and then just let me know. Okay, yeah, if you don't have any questions, Mas dan Mbak, I'm going to show you my screen. There you go. Okay, now we are done with test of normality. The concept, why we need to run the analysis, how to run the analysis, how to interpret the output, and how to write the report is okay. Now we are going to have a look at the next type of analysis, that is correlations. This is the next basic type of correlation before we come to uji beda and regression. Okay, now, well, in the world of statistics, normally we split types of analysis into these two. Meskipun nanti ada juga jenis yang lain di sini, but we are not going to talk about the other one or some other ones. We are talking about these two. The first one is, if your purpose is examining differences between groups, then you are going to run t-test and ANOVA, something that we are going to have a look at a couple of weeks, in the next, probably next week. What does this test of difference mean? I mean, examining differences mean. So for instance, you have two groups, laki-laki dan perempuan. You want to see apakah ada perbedaan signifikan antara lama durasi laki-laki dan perempuan dalam mengalami vertigo misalnya. Kayak kasusnya Mbak Pratiwi tadi. Apakah lebih lama laki-laki ataukah lebih lama perempuan misalnya. Karena theoretically katanya kan perempuan lebih banyak pakai perasaan, sedangkan laki-laki lebih banyak pakai otot katanya. But we need to check it, for instance. It was just based on your curiosity and based on the backup theories, misalnya. And then you run t-test or ANOVA later kalau ada kelompok yang lainnya di sini. This is the first type of analysis, first group of analysis. The second group of analysis is examining relationships between variables. For instance, you want to see whether students' anxiety in statistics or data analysis class is related to their vertigo, misalnya. Kekambuhan vertigo itu dipengaruhi kelas statistik atau tidak, misalnya. I mean, tidak nyindir Mbak Pratiwi ya, because vertigo is always, I mean, is there. You cannot expect it to come, but you cannot also expect it to go, I mean, like within 1 minute or within a second. Karena ya nggak enak sekali. Okay. So, is there any relationship between someone's anxiety and their speaking performance, misalnya? Is there any relationship between someone's feeling of insecure and their speed in finishing or completing their thesis, for instance? Because theoretically, students who feel scared or insecure with their supervisors, they tend to work slower and they tend to complete their thesis longer, misalnya, theoretically. So again and again, because in quantitative studies, we normally test the theories. That's why we are doing these two type of analysis paling banyak. These are the ones that we are going to talk about in the next couple of weeks. But first, we are going to have a look at the most simple one first, the simplest type of analysis, that is uji korelasi. Okay, so what is actually uji korelasi? An example or some examples of uji korelasi are this one. Tapi ini aneh-aneh. They do not belong to our field. Misalnya, is there any correlation between children's IQ and parents' IQ? Misalnya, kalau yang anak-anaknya, orang tuanya itu S2, maka anak-anaknya lebih pinter nyari jodoh yang S2, kecuali yang sudah menikah. Nggak boleh lagi, nggak boleh nambah. Jangan nambah dulu, biar yang belum kebagian. Okay, so this is just an example. Probably there are like if the two parents are excellent or are brilliant, then it is likely that their children's IQ are also high. Misalnya, theoretically ya, but belum terbukti. Or another example is this one: number of police patrol and number of crime. The more patrol the police officers do, the less number of crime may exist, misalnya. Or another example is grade on exam and time on exam. If you provide longer time for the exam, it is likely that the grade on an exam will be higher. But if you decrease, misalnya diperpendek, if you shorten the time of exam, it is likely that the student's grade on that exam will get lower, for instance. So these are just some examples of how correlational studies or correlation analysis work. In the field of ELT, we may find many examples of this correlation. For instance, someone's vocabulary mastery and their reading comprehension, or someone's vocabulary mastery and their speaking achievement, someone's grammar mastery and their writing scores, someone's reading performance and their writing performance, someone's listening performance and their speaking performance. So there are many correlation examples of correlational studies. If we are talking about ranah apa tadi, cognitive. Ini yang cognitive tadi, scores. But we can also talk about non-cognitive domains, like affective domains, something related to psychology. I already gave you some examples. Misalnya, how is someone's anxiety in public speaking related to their speaking performance, misalnya. Or how does students' autonomy in reading affects their speed in completing their thesis, misalnya. Or how does teachers' perception on assessment for learning concept affects their students' confidence in working on a test, misalnya. So these are some examples of non-cognitive domain correlational studies. The one on cognitive domain correlational studies itu yang tadi yang related to scores or performance. Okay, now let me go to the next slide. When we are talking about correlation, later you will find correlation coefficient. What is correlation coefficient? Later, come on. Correlation coefficient is an index that you will find as the output of your correlational analysis, and it will show the magnitude atau the power of your correlation. This power of correlation shows how two variables are associated or related. Let me jump to that page. Okay, so we are going to find these numbers as the output from our, what is it? Tests of correlation analysis. Later, you will find that correlation index ranges from -1 to +1 or -1 to 1. Okay, so the more the bigger the number, the stronger the correlation is, or the magnitude is stronger. Okay, so later you will find that if the magnitude of the correlation is between 0 to 0.3 or between 0 to -0.3, then it will show weak correlation. If it is between 0.3 to 0.7 or 0.31 to 0.7 or -0.31 to -0.7, it will show moderate correlation. If it is larger than 0.7 or -0.7, it will indicate strong correlation. So this minus or plus doesn't have anything to do with the power or with the magnitude. It will just show the relationship. What does positive and negative relationship mean? I'm going to explain it in a bit. Let me just go back to my slide. Okay, before we go ahead with positive and negative correlation, basically in statistics we try to observe the power or the magnitude of correlation from this scatter plot atau dot-dot yang ada di sini. This single dot represents the scores, individual score. Ini individual score 1, 2, 3, 4, 5, individu kelima sampai seterusnya sampai sebanyak ini. Okay, but you are not going to observe them in SPSS. We are going to see it from a particular table later, a specific table that we are going to show in a bit. What about positive and negative correlation? Okay, what is meant by positive and negative correlation? When we are talking about positive correlation, we are talking about how one variable, the case in positive correlation is when one variable gets increases, the other variable decreases, or positive. One variable increases, the other variable increases. One variable decreases, the other variable decreases. Jadi satu naik ikut naik, satu turun ikut turun. And negative correlation means tidak searah, tidak seias kata. Satu naik, satu turun, satu turun, satu naik. Let me give you an example. Okay, the first one is an example of positive correlation. So for instance, we take this data. Listening, speaking. When the first student's score in listening is 50, his score in speaking is also 50. When the second student score is like 70, his speaking score is also like 75. And then when someone scored, third score is like 30, his speaking score is also low, 25, for instance. When someone's score in like 90, then it also gets up like 92, for instance. So you can see here that when the individual score is in the middle, then the individual score in listening is di tengah-tengah, then his or her speaking score is also di tengah-tengah. Kalau di 3/4 atas untuk listening score, speakingnya juga 3/4 atas. Kalau di bawah, maka dia di bawah juga. So if we may draw it into a table, misalnya tabelnya seperti ini listening, ini speaking, 10, 20, 30, 40, 50, 60. 10, 20, 30, 40, 50, 60, 70. The first score, 50 and 50. 1, 2, 3, 4, 5. Somewhere here, misalnya. 70, 70. Somewhere here. And then 30, 35. Somewhere here. 90, 90. Somewhere here. So you will find that this dot will form a line. Right? Meskipun garisnya mungkin tidak sempurna, tapi membentuk garis. Dan ketika satu variabel ini naik, variabel satunya juga naik. Ketika variabelnya satunya itu rendah, variabel satunya juga rendah. This is what is meant by positive correlation. Okay, what about negative correlation, sir? The other way around. And you will always find tanda negatif di sini. An example of negative correlation is this one. Anxiety in speaking and speaking performance. Students 1 anxiety in speaking is low, for instance, 20. And then his speaking performance is really good, 80. The second student, his speaking performance is in the middle. And then his anxiety is in the middle. His speaking performance is also in the middle. The third student, his speaking anxiety is high. And then his speaking performance is a bit low. Dan seterusnya, misalnya di sini 75, ya di sini 30, for instance. So if we draw it in this scatter plot information, or like a table, not table, yes, in the scatter plot, you will find this one. Misalnya ini anxiety, ini speaking performance. Di sini 10, 20, 30, 40, 10, 20, 30, 40. Ini anxiety-nya 20, maka speaking-nya tinggi. Ada di sini misalnya. Ketika ininya 50, maka berada di 50 juga. Ketika ininya anxiety-nya 80, maka speaking score-nya di sini. Ketika ini 75, maka berada di sini. So this will make this line. Kebalik ya garisnya dari yang tadi ya. Kalau tadi gini, yang ini gini. Okay, this is what is meant, or the idea of negative correlation. When one variable goes up, the other variable goes down, and when one variable goes down, the other variable goes up. Selumpatan namanya dalam bahasa Jawa. So this is the basic concept of positive and negative correlation. What about the what is it, kerapatan dari ininya Pak? Apa garisnya Pak? This kerapatan or this density tells us about the magnitude or the power of the correlation itself. So if we have a look at the next slide, this density, this correlation is perfect because it creates, or it forms, a perfect line. Nyambung garisnya. But in reality, having one as the correlation index is almost impossible because it is like seeing yourself in front of the mirror. Melihat diri kita di depan kaca, yaitu yang kita lihat, diri kita. Okay, and the other one, for instance, 85. You find that the density agak nyebar, tapi masih membentuk garis yang manis, tipis seperti ini. Garisnya ramping. Okay, the next one, medium correlation, mulai agak nyebar di sini. Garis tapi agak nyebar. The last one, weak correlation, nyebarnya nggak karuan. Okay, so you get this one, very thin line, kind of thin line, a bit fat line, and then this is fat line misalnya. The fatter the line is, or the fatter the scatter is, then the lower the magnitude of the correlation index. Nah, yang kita harapkan nanti yang tipis-tipis seperti ini. Atau maksimal ya seperti ini. Nah, ini tadi angka yang di sini itu yang correlation index, magnitude tadi. Aturannya seperti apa? Kalau R-nya ini antara 0 sampai 0,3 atau 0 sampai minus 0,3, this one is weak correlation. Okay, if the R is 0.31, come on, 0.31 up to 0.70, atau di sini ada tanda negatifnya, then it is moderate or medium correlation, moderate correlation. If it is higher than 0.71, then it is likely to be strong correlation. You get it? Atau minus. The minus or the plus doesn't make any difference on the magnitude of the correlation. Okay, now I'm not going to talk about this one. I'm pretty sure that you don't want to do this. By hitung tangan nggak mau ya. Jangan Pak, saya ngambil bahasa Inggris supaya nggak ngitung kok malah suruh ngitung. Come on, yeah. Nah later, when we run correlation analysis using SPSS, you will find this as an example of your output. I told you just now, if you have 1 as the correlation, it's just like seeing yourself in front of the mirror, making a correlation, finding a correlation between shyness and shyness. Ya, tidak mungkin shyness dikorelasikan dengan shyness pasti 1, karena skornya sama. But if you have this one, for instance, minus 0.79, this indicate a negative correlation, but the number here indicate the magnitude, strong negative correlation. Now I'll show you another example. This one, the one that we saw just now. Misalnya di sini, ini tadi aturannya ya, ini kita ambil 31 biar tidak bingung. Pak, nanti kalau 0,3 terus gimana ya, kita buat 31 atau 71. This is an example. The correlation is minus 0.849 or 0.85. This one suggests 85 itu di mana posisinya? Oh, berada di sini, lebih besar daripada 0,7, tapi pasti itu strong correlation. Tapi tandanya minus, maka negative correlation. Tapi strong negative correlation. Kalau positif ya nanti strong positive correlation. Kalau moderate ya moderate negative or positive correlation. Kalau weak ya weak negative or positive correlation. Yang penting ingat angka di sini. Okay, I'll stop here and I'll open a question and answer session. So if you have any questions, silakan ditanyakan terlebih dahulu. Ternyata senam itu kalau untuk orang yang tidak pernah senam malah bikin sakit, bukan bikin sehat ya. Badannya jadi kaku semua habis senam. Oh my goodness. Yeah, if you have any questions, Mas dan Mbak. Because if you don't, then we are going to have a go with how to run the analysis. We just learned about the concept, the why, and then later we are going to have a look at the how. Going, gone. If you don't have any questions, now we are going to have a look at how to run the analysis. Yeah. We are using the same data, assignment 1. Can you see my screen on SPSS screen?
Yes, Bapak.
Yes, perfect. Now we are going to have a look at how these variables are related one another. Kita coba lihat dulu bagaimana intro to research is related, scores in intro to research is related to research design. Remember, you can only run this type of analysis on ratio type of data. Tidak bisa untuk nominal. Gender di apa namanya dikorelasikan dengan SIS ya tidak bisa. Because they are nominal. Now we are going to have a look at intro and research design. So you go to analyze. Kalau ini lebih mudah karena ada correlate langsung di sini.
Sorry,
Analyze.
Bapak.
Yes.
The screen is not moving. Or
Really?
it's just mine.
Actually, this is still PowerPoint, Bapak.
Oh, that's why I asked you whether you already saw my screen or not. Okay. Can you see my screen now?
Yes, Papa.
Yes, we are going to have a look at how intro to research is related to research design. So we first go to analyze and then correlate and then bivariate. Okay, again, analyze, correlate, bivariate, and then click on this. Mana tadi yang mau dianalisis? Intro research and research design. Intro to research, bring it to the right. Research design, bring it to the right juga. Yang lain dibiarkan saja. Pastikan yang ini terklik. Flag significant correlations. Karena dari sini Mas dan Mbak nggak usah bingung mana yang signifikan korelasinya, mana yang enggak korelasi signifikan. Karena kalau ini pakainya nanti sig juga. Tapi signya harus terbalik dari yang tadi. Kalau uji normalitas tadi kan signya harus lebih besar dari 0,05. Ya kan? Kalau ini untuk dianggap sebagai korelasi yang signifikan, ini harus lebih kecil dari 0,05. Maka daripada bingung lihat signya, pastikan ini tercek karena nanti ini akan menunjukkan mana yang signifikan, mana yang enggak. You get it? Kalau itu sudah tercek, and then klik OK. Now you get this table, correlation table. Nah, this is what I meant. These two asterisks shows you that the two variables are significantly related. Two asterisk significantly related. One asterisk, sir. Yes, it is significantly related. Hanya nanti kalau dilihat lagi di signya ini pasti lebih kecil dari 0,05. Sedangkan kalau 0,01 kalau asterisknya 2. Kalau asterisknya 1, signya pasti lebih kecil dari 0,05 saja. Bisa 0,4, 0,3, 0,2, 0,1. Tapi kalau 0 lebih kecil dari 0,01 pas 0,01 pasti 0,001 atau 0,00 berapa. And here you find it here. The sig is 0.000. It shows that this is significantly related. So this asterisk, single asterisk or double asterisk, this indicate that the two variables are significantly related. And this is what we are looking for. Ada hubungan yang signifikan. But remember, this correlation doesn't suggest any cause and effect relationship. Belum sampai ke sana. Mungkin indikasi, mungkin ya, but not yet. We do not talk about that one first for now. Okay, now if we have, let us go back to this table. Please have a look at this column. Okay, if you have a look at this column, you find that the R itu adalah Pearson correlation ini. Berapa di situ R-nya? 0.762. Okay, and this is significantly related, indicated by the two asterisks. Kalau asteriknya 1, Pak, ya masih tetap significantly related. Kalau tidak ada asteriknya, tidak significantly related. I'm going to show you the example later. But we are talking about this one first for now. Now, this variable, I mean, this number tells us that research design and intro to research are significantly related. We see it from the two asterisks. What about the power? What about the magnitude? Tadi di atas 0,7, maka dia strong. Maka ini berarti strong positive correlation. That intro to research design and research design, intro to research method and research design are strongly related. And if you want to make it complete, then there are strong positive correlation between intro to research method and research design. Nah, kita coba lihat. Masih bingung? Kita coba lihat berikutnya. We'll have a look at how the other variables are related. Let's collapse them all. Kita collapse saja ke kanan, kemudian klik OK. Nah, tabelnya jadi banyak kayak gini. Tambah pusing, Pak? Ya, enggak apa-apa. Nanti pusing itu artinya proses. Coba Mas dan Mbak lihat, ada yang berasterik enggak di situ? Antara apa dan apa? Tadi research design dengan research intro to research sudah ya. Ini OK. Berarti ini juga OK karena sama. Can you find any other significant correlation from the table?
Thesis score dengan intro research introduction, sir.
Okay, intro and thesis score. Yes, this one. You get 2 asterisks here, right? Iya kan? Nah, let's see. Kira-kira ini positive or negative correlation?
Positive, sir.
Positive. What about the magnitude? Is it strong, moderate, or weak?
Moderate.
Moderate. So there is a moderate positive correlation between intro to research and thesis score. Gitu ya. Can you find any other significant correlation, Mas dan Mbak? Tadi ini sudah, ini sudah, ini sudah, ini sudah.
Academic stress score, sir.
Academic stress score and
Introduction to research method.
Oke, kita lihat di sini. How do you know? That it is significantly related, that they are significantly related.
There's 2 asterisks.
Okay, you got 2 asterisks here. Is it positive or negative correlation?
Negative, sir.
Negative. What about the magnitude? Is it strong, moderate, or weak?
Moderate.
Moderate.
Moderate. Di atas 3 ya. That's why there is a moderate negative correlation between intro to research and academic stress score. Check. Check. Is there any significant relation, Mas dan Mbak?
Thesis score and research design, sir?
Thesis score and research design. How do you know that there is a significant correlation? Dari mana? Ini ada asteriknya kan? Ada 1 asterik, 1 bintang itu ya. What about the magnitude? Is it positive or is it positive or negative?
Positive.
Positive. What about the magnitude? Is it strong, moderate, or weak?
Weak positive correlation.
Okay, there is a weak positive
Positive
correlation
correlation.
between research design and thesis
thesis score.
score. Cek, cek. Nah, coba lihat yang lainnya di sini. Kita coba lihat yang mungkin agak tinggi. Oh, enggak ada yang tinggi ya. Misalnya di sini. Have a look at this table. Can you find any asterisk there?
No.
No,
No.
sir.
Kalau enggak ada asteriknya, pasti ini di atas 0,05 signya. Coba saja dilihat signya di sini. Yang enggak pakai asterik pasti di atas 0,05. Iya kan? It tells us that there is no significant correlation between the two variables. We can only run correlation between two variables. Okay, now kindly have a look at the other variable that I sent to you. Tadi saya kirim file apa saja?
Exam correlation exercise 1, 2 sama assignment 1.
Exam correlation correlation exercise 1 ya.
1 sama 2 ya.
Oke, now kita coba correlation exercise 1. Correlation exercise 1. Okay, open correlation exercise 1 and then run a correlation analysis for speaking, writing, and anxiety. Again, open correlation exercise 1 and then run speaking correlation analysis for speaking, writing, and anxiety. Saya juga akan running itu. Yes, do we have the same table? Do we have the same table? So do we have the same table, Mas dan Mbak? Do we have the same result?
Yes, sir.
Yes, sir.
Yes. Now, can you read this table? Gimana cara membacanya? Is there any correlation between speaking and writing?
Yes.
Yes. How do you know there is a significant correlation?
Because there is 2 asterisks.
Okay, that you find 2 asterisks atau dari sig value-nya lebih kecil dari 0,05 ya. Sebenarnya ini, tapi SPSS itu memberikan bantuan dengan asterik. Okay, what about the magnitude? Is it strong, moderate, or weak?
Strongly positive, sir.
Strong, and the direction is positive. So there is a strong positive correlation between speaking and writing scores. What about speaking and anxiety?
As a correlation.
There
Strong
is a
negative
correlation.
correlation.
Strong negative correlation. What about writing and anxiety?
Strong negative too, sorry.
Strong negative correlation. Okay, so up to this point, if you have any questions, Mas dan Mbak, feel free to ask. Silahkan. Yuk. Karena kalau tidak, we are done with the how and why, what and why, how, and I mean running and interpreting the output, and then later we'll learn about how to write the report. Any questions, please? No, going, sudah pusing ya, ya udah enggak apa-apa. Sudah ini terakhir, materi terakhir. Okay, now if you don't have any questions, this is the one that I want to share with you. So this is an example of how to write the report of correlational studies that I take from Statisticlert. So Google and then type the type of analysis and then Statisticlert or Statisticlert and then type of analysis and then click OK. It will give you this type of this kind of report. Let's say a Pearson product moment correlation was run to determine the relationship between writing scores and speaking scores. There was a strong positive correlation, which was statistically significant. Ditulis R-nya berapa, R itu angka yang paling atas, N-nya ini dihilangkan saja, enggak apa-apa, enggak perlu pakai N ya. Kemudian P-nya apa, itu sig-nya di situ. Oke, jadi ini kalau kita rubah dari contoh kita tadi, misalnya ini tabelnya ada di sini, saya copy dulu, taruh di sini. Okay, I just pick up the Microsoft Word. It doesn't get along with PowerPoint slides. Nah, misalnya seperti ini, and I'm going to highlight this one. So a Pearson product moment correlation was run to determine the relationship between speaking and writing score, students speaking scores and their writing scores. There was a strong positive correlation between speaking and writing scores, which was significant, which was statistically significant. Saya akan highlight kuning, saya akan highlight hijau so that you can distinguish it. Hey, I'm asking for a green one. So this one will be green. And this one will be yellow. And I'm going to change the numbers there. There you go. The green goes with the green, the yellow goes with the yellow. You may want to snapshot it. You want to take a picture. Is everything okay? Sudah mau terbakar Pak otaknya. Jangan khawatir, this is just simple analysis, don't worry. I'll stop the recording because it's almost there.